Hi, thank you for having me. Thanks for having me in Chicago, where my weather will actually in San Francisco be exactly like this when I get home. I want to do a little calibration for the talk first. Are there any scientists here? I can just make you out if you raise your hand. Are you scientists? A couple in the room. Are there any drinkers? Okay, so I'm among my people. As Hakeem implied, other people have talked about booze before. Here's one. You know who that is? It's Ben Franklin. Franklin is supposed to have said, "Wine is proof that God loves us." That's a charming sentiment. It's actually a misquote. What he actually said was that rain falling on grapes, which can then be made into wine, are a constant proof that God loves us and wants to see us happy. Which I actually like better than the misquote, because it implies a more direct connection to the divine, or if you'll permit me a Chicago accent joke, to divine. Nobody, really? Nothing? I'm gonna keep doing those. That's how this is gonna go. We're doing this now for I got 13 more minutes. It's all stupid puns. That's actually not my favorite booze quote, though. My favorite booze quote comes from this gentleman. You know who that is? It's a harder one. That is noted drinker William Faulkner. Faulkner said this: "Civilization begins with distillation." So he was a great writer, and obviously he was trying to do something metaphoric there, right? He was trying to say, distillation is about getting to the essence of something. It's about getting to basics, getting down to some ground truth. And that's probably true, but I actually, because I have some training in science journalism and because I'm not as good a writer as William Faulkner was, the book is great, though. I actually think he was being literal. I actually think that our relationship with alcohol is a kind of hologram or model for our relationship with the physical world that Hakeem was just talking about, with the natural world, with our environment, and with the technological world that we all build, with the engineered world, the scientific world that we make today. So I'm going to try to prove that in the next few minutes. Starting with, do you recognize them? I'm not going to do that joke over and over again, but that's yeast. That's Saccharomyces cerevisiae, or sugar fungus beer maker. Which is a little on the nose, right? It's brewer's yeast. It's the stuff that converts simple sugars into ethanol and carbon dioxide. Ethanol is the alcohol that we drink. Nobody knew that yeast did that until the 1860s. Human beings have been, as I'll talk about in a minute, consuming alcoholic beverages for at least 10,000 years, and nobody knew how it worked until Louis Pasteur in some of his early work. Pasteur's work on yeast and beer and wine was like his playing small clubs in the East Village before he started to play arenas with pasteurization and rabies and stuff. That's how he started, was figuring out that yeast was the agent of fermentation. But you could ask the question, why does this 150 million year old organism ferment? Why does it convert sugar to ethanol? I don't mean that in a philosophical or existential sense, because it's a fungus. That would be weird. No, but I mean in an evolutionary sense. What's the point? What is the point of booze? Don't panic. I'm not going to keep doing this to you. This is exactly why I, in college, ended up being a journalist and not a biologist. This is the yeast metabolic cycle. This is how yeast takes glucose, which is a simple sugar, makes it into ATP, the green thing, that's fuel in the body, and excretes ethanol. But what I want you to pay attention to is the little box at the bottom, because what the little box at the bottom shows with the two arrows is a chemical called acetaldehyde getting made into ethanol by an enzyme called alcohol dehydrogenase 1, or ADH1. But it also shows ethanol getting made back into acetaldehyde and consumed, put back into the process to make energy by another enzyme, ADH2. So in other words, yeast can excrete ethanol, but yeast can also eat ethanol. So yeast can eat its own poop. That's what I'm trying to say. That's a thing that yeast can do. So why? Why do they do those things? Well, you know what alcohol is good for, right? You have rubbing alcohol in your house right now. What do you use it for? You use it to kill germs. Alcohol is a really good antimicrobial. It's really good at killing the things that compete with yeast for food. So the question is, is yeast making alcohol because it's doing chemical warfare on its neighbors? Or is yeast making alcohol because it wants to store in its environment food? How do you figure that out? That's what this gentleman tried to solve. His name is Stephen Benner. He is a paleogeneticist. And he realized that what he could do is he could take a bunch of examples of those ADH enzymes and do what linguists do when they want to know what like this ancient Sumerian word for house is by comparing all the words for house that exist today. He could do the same thing with enzymes. He could take all those examples and use them to deduce what 12 versions of that primordial enzyme looked like. He called it ADHA, alcohol dehydrogenase A. And then he just ran the kinetics. What does it want to do? Does it want to change acetaldehyde to ethanol, or does it want to change ethanol to acetaldehyde? Does it want to make ethanol, or does it want to eat ethanol? He ran the numbers, and it turned out it was more like ADH1. It wanted to make ethanol. So you go, oh, okay, problem solved. Yeast obviously is committing chemical genocide against its fellow bugs. But no, because the question really is not why is it making ethanol? The question is, where is yeast getting sugar? Because 150 million years ago, there wasn't sugarcane yet. Sugarcane's a grass, it hadn't evolved yet. Yeast, when they first showed up on the scene, probably lived on what research called tree sap exudates, so little blebs of sap that come off of a tree. And 150 million years ago, the trees were all conifers, you see on the left, pine trees. That's what there was. But then, and they lived outside, right? So ethanol, which is really volatile, it likes to evaporate. That's going to be important later. Ethanol, as a waste product, would just blow away. It's really useful in a waste product. You don't have to build a sewage system. But then 50 million years ago, something happened. The Cretaceous period. It's exactly what you were thinking. 50 million years ago, it's the Cretaceous period. Well, what the Cretaceous period was all about was the development of fruiting, flowering plants. That's Ambarella up there. That's the first plant with fruit. What happened is that yeast, because they were already able to consume sugars and live in a higher ethanol environment, were in some senses pre-adapted for a universe where all the plants had fruit and flowers. If you were an animal or a fungus or whatever alive at that time, then the Cretaceous period was a genocide event for you. You weren't ready. You couldn't survive. But yeast could. They looked pre-adapted. Actually, it was more like luck. That's why yeast make ethanol, because they were trying to get rid of it first. I'm going to jump ahead about 50 million years. You can move that fast in a talk. This is a shard of pottery from a place called Jiahu in China. It's a really interesting archaeological site. It has some of the first examples of rice as a foodstuff, first examples of written language, musical instruments, and also had this pot with a weird residue on the inside. When Patrick McGovern, who's a researcher at University of Pennsylvania, looked at that residue, did some analytical chemistry on it, he found evidence of three things. He found beeswax, which meant that it contained honey. He found tartrates, tartaric acid, which would usually mean grapes. In this case, probably meant hawthorn fruit. And he found, so he's got rice and found evidence of rice. So he's got sort of rice, grain, fruit, honey. And he realized that if you combined all those things in a pot, you basically would have trouble keeping them from fermenting. He doesn't find ethanol, again, because it's volatile, evaporates. But he realized that this was the oldest evidence of human-controlled fermentation. This is the oldest cocktail. This is the Mother Eve of booze. You get grain, which is beer and whiskey. You have honey, which is mead. You have fruit, wine, or brandies. This is the oldest stuff. 10,000 years we've been doing this. And like I said, the people who made this didn't know why it worked. They didn't know that there was yeast in the environment that was fermenting. They just knew they could ferment. This is where they started. I lied. There's one more of these. This is it. But I promise, this is the last one. This is glucose. This is the sugar that I mentioned. Glucose is an amazing molecule. Sugar in the world is power, right? It's one of the ways that our bodies store fuel. We consume it for energy. It's also structure. You can build with sugar like Legos. You can make, this is a monosaccharide, but you can make polysaccharides, multiple sugars, and so that's starch. You can combine it in a different way and get cellulose. You can combine it in yet another way and get chitin, the stuff that insect exoskeletons are made out of, and octopus beaks. Nature's really weird. So glucose is also, as I said, what yeast consume. So where do you get it? Well, grapes are really good. Grapes are 25% simple sugar, and yeast love to live on the outsides. Honey is fantastic. Honey and water, put it away for a while, you get mead. Apples are terrific. Fermented apples, cider, was what the North American economy was based on for hundreds of years. And it's a value add, right? If you're trying to make something, if you're trying to ferment something, you can take this agricultural product and take a whole field and turn it into one barrel and then take that to town and sell it for more than you could just sell the stuff for. It's great. But what if your agricultural product stores its sugar as starch? So the problem is that yeast can't digest starch. You and I can, right? We can't digest, I don't know, maybe you're a superhero mutant or something, but if you're all regular human beings, you can't digest cellulose, wood, and paper, right? We can digest starch. We have enzymes in our saliva that begin that process called amylases, but yeast can't even do that. It has to be simple sugar. So what human beings learn to do is take grains, which are these little bombs of life. They're like, they store energy as starch, just the way a chicken egg stores energy in an egg yolk. And when they're ready to grow, they make the enzymes that convert that starch into sugar for the little embryo in the seed. They're really amazing it's an amazing bit of nanotechnology, if you want to think about it that way. What we learned to do is a process called malting, to saccharify these starches. We want to turn the starches into sugar. This is Glenord malting in the north of Scotland. It's near Inverness. It's one of the 6 facilities that Diageo uses to make the malt for all of its whiskey. So we learned to feed the yeast. We like to think that we domesticated yeast to ferment and distill. They domesticated us. We feed them sugar. Unless you're making any of the booze from the east, like sake or shochu, in which case you use another fungus called koji, which we domesticated and domesticated us. It's an aspergillus. Most of those are really dangerous. They're toxic or carcinogenic. Not the ones that they use on rice that convert the starch in rice to sugar so you can make sake. I'm going to jump around a little bit. This is Alexandria, where all that like Antony and Caesar and Cleopatra drama happened, and the library thing, that burned down. Alexandria was an amazing city. Alexandria was the first city of engineers. They loved robots. They had all these automatons in the temples that would you'd go in and the doors would open automatically and a flame would come on and a robot bird would sing, stuff like that. They were a city of engineers. They were also a city of alchemists. And the alchemists get a bad rap because the alchemists, most people think, were just really terrible at science. And it's true, they were wrong about almost everything in terms of what the chemistry was that they were doing, but what they did get right was methodology. What they learned how to do was experiment. They were the beginning of experimentation as a scientific method, especially this woman. This is a woodcut of Maria the Jewess. Don't write me letters, that's what history calls her. I didn't come up with that. She invented something called a bain-marie. It's a Marienbad. It's like a double boiler. They still use it in laboratories. You'd find one on this campus today. She also invented, if you believe the historians, this. That's a keratokis and a tribikos. Sorry, my ancient Greek is terrible, but you combine those together and you get what in the Arabic is called an alembic, or an alembic, a still. What she'd figured out was a separation technology, was a way to use heat to separate molecules based on when they evaporate. So things that evaporate first are lighter, they go over the top of the still first, then you get a middle level, that's where ethanol is, and then a last set. And now she probably wasn't distilling anything alcoholic. She was an alchemist and was interested in the Philosopher's Stone and was probably looking at sulfur, although I like to think that her lab was like every graduate lab and that there was always booze in it. And they had access to Roman wine in Alexandria. I figure somebody tried it. But really, you don't see what we would consider distillation for drinks until about 1,000 years later. This is Taddeo Alderotti. He was an Italian physician, a doctor. He wrote a book called Consilia Medicinalia, where he first starts to talk about this amazing substance, this miraculous stuff that could make you feel better if you were in pain, and would preserve foods, and would give you fresher breath, and would extract the essences of herbs. You can imagine if you lived in a world where they hadn't discovered any medicine yet, where no chemical worked and where you still believed in magic, the idea that somebody could make with a device that they engineered themselves a chemical that actually made you feel different and made you taste things that you hadn't tasted before would seem like magic. And it actually worked. He actually had it. It spread across Europe. It spread across the world. We end up with places like this. This is my favorite craft distillery. When you write a book about booze, you get to have a favorite craft distillery. This is St. George Spirits in Alameda, near Oakland. They make a lot of really interesting gin. And what you see there is the same technology, essentially, that Maria invented. You see the still, a boiler, you put stuff in the boiler, you boil it. If it's fermented, it goes over the top. Some of it you throw away, some of it you keep. The stuff that we keep is what we drink. Same technology today. A couple of months ago, I went to Japan with my family, and in Tokyo, there's the Imperial Hotel. It's mostly new, but the first Imperial Hotel was built by Frank Lloyd Wright. Like most buildings that Frank Lloyd Wright built, it fell down in the 1960s. But you can't insult Frank Lloyd Wright in Chicago, can you? It did, it fell apart. Everything is gone that Frank Lloyd Wright built there except one place, the bar. The bar is still all of Wright's original appointments. So I wanted to go see it because I care about Frank Lloyd Wright and I care about drinking. So I went to the bar. I got that drink. I don't actually remember what the drink is called. It wasn't that great. The coaster's beautiful though, right? And I bring this up because the reason that I went was that in that space, I was able to find a connection to some history of architecture that I care about, and also to this deep time history that I'm trying to talk about with booze. Scientists now are able to genetically see the genetics of a yeast, to take apart koji and try to understand how it works, to industrialize the entire process of making booze. But we still sense in it magic. And I would, I guess, paraphrase Arthur C. Clarke a little bit and say that that magic is really just advanced technology. The science of this stuff is how we make that magic. And when you were drinking it, you were tasting 150 million years of biology, 10,000 years of human history, 2,000 years of human engineering. I would say that when you were drinking it, you're tasting civilization. Thank you.